morning all, and welcome to the first Breakfast with Relog session for the year 2023. We will be discussing the energy solutions in distribution centers with a specific focus on lithium batteries. Lithium batteries is quite a hot topic and are used extensively for energy storage technology for many applications. This ranges from small and large electronic devices to electric vehicles to grid-scale energy storage systems. Lithium batteries are becoming more popular, especially in residential homes, and companies, as our need for energy storage solutions are required to be more compact, more portable, longer lasting, and in some instances, an answer to load shedding. Lithium battery benefits are largely due to their size and their ability to charge rapidly. Despite their technological promise, lithium batteries still have several shortcomings, particularly with regards to safety. But I'm sure we'll get into that during this webinar. We have curated today's webinar with experienced professionals in various fields to shed some light on all these questions regarding lithium. At the end, we hope to have informed our viewers to have a better understanding of lithium batteries and its viability for their operations. The running order of this webinar is displayed on the screen with the various key topics from each speaker. Each presentation will be about 10 minutes, which will allow some time for the Q&A session afterwards. In this session, the panel will answer any questions from our viewers. Please don't be shy to ask, as this is a wonderful opportunity to engage with the experts. I would also like to inform our viewers that there will be a recording available of the webinar on our website and on our YouTube page after this session. With that being said, and without further delay, let me introduce our first speaker, Mr. Anton Kutsia. Anton currently heads up the project delivery department at Relog. Relog is a retail and logistics consulting firm specializing in designing and implementing bespoke and sustainable distribution infrastructure, logistics operations, and supply chain networks. Anton has been working in the retail and distribution space for more than 10 years. He has significant experience in the implementation of distribution infrastructure and coordinating multi-million logistics projects. Welcome, Anton.
Good morning, Mark. Thanks so much for the introduction. Right, good morning to all the listeners. Just want to get sharing my screen over here. Right, yeah, so as Mark has mentioned, lithium ion is a hot topic, and overall, if we look at energy and so on, there's been an increased focus on our environment, and energy consumption has become a significant element to consider as part of warehousing and distribution center designs. And we see large corporates having to report annually on their energy consumption, and they invest millions to try and reduce their impact on the environment. And with people becoming more conscious of their own habits and being more environmentally responsible, it is becoming a marketing factor for retailers and the like. So it's therefore imperative that we seek for opportunities to reduce our electrical consumption in the warehouse to contribute to a more sustainable operation. Environmental change is driven by governance, and at this stage, there's not much South African legal regulations governing what we should or shouldn't do. But it's obvious from a global approach and a global view that this is the approach we should be following. Right, so if we just briefly look at the typical energy users in our DCs, there's many elements that contribute to the electrical consumption and demand in the warehouse. If we just look at a few of these big consumers in the warehouse, we can look at refrigeration, which is a very large consumer of energy. That's, of course, if that's applicable to your DC environment. Lighting is a big one, battery charging, and ventilation and air conditioning. Today's session is more focused on the battery charging element of it all. So if we look at a brief view of how batteries have changed in the world, batteries have become irreplaceable in everyday life. The first batteries were invented back in the 1800s, and that's 200 years later. We can almost not imagine a life without batteries and the convenience of portable power, which we use on a daily basis. While single-use batteries is very common, such as use of flashlights and toys, the biggest advancements have been made in the mobile battery technology, and we've seen this leap in the automotive industry and electric vehicles where lithium is most commonly used. And lead acid and lithium ion batteries have been the most common battery chemistry types that we've used. And while lead acid is still widely used, lithium ion has gained popularity due to its multiple benefits that it offers, which we'll get into just after this. And the market for lithium ion is growing a lot. and a lot of technologies are adopting lithium-ion technology and its benefits. I mean, if we consider the mobile phone, if you remember those big antenna brick phones, and you compare that today, how much computer power, big screens, the iPhones and the like have got these days, and how small the battery has become. It's amazing to see how that is evolved and how it's still growing every single day. But also just to consider the contrary, while lithium-ion is a very good solution in materials handling operations, it doesn't necessarily suit every single operation. And it's important that we consider all the benefits and all the requirements to the operations, and that it meets your business needs. So material handling systems that you're using, the operating environments, and looking at those. So if we just skip to the advantages of lithium. Many of you will be familiar with all of these, but if we can just run through it. If we look at battery life, lithium batteries last longer than lead acid batteries. If we look at 5,000 to 6,000 cycles compared to about 1,500 cycles for lead acid, if the batteries are maintained properly. The most common benefit for lithium-ion is the ability to charge the battery at any time, regardless of the state of discharge, which is referred to as your opportunity charge. Another benefit is fast charging. Obviously, lithium batteries can be charged quickly and therefore lends itself to quick charging when there is small time frame available, like lunch or tea breaks or other intermittent tasks that need to be done in between. Lithium-ion batteries are also lightweight and compact. So compared to their conventional lead acid batteries, the equivalent amp hour lithium battery is much smaller while providing the similar cycle times. Low maintenance. There's obviously no water top-ups required as you've had in lead acid, and there's no emissions. It's also less labor intensive, obviously, in the battery bays, and there's less risk of damage or battery injuries if there's not much swap out required. There's obviously there could be the opportunity of changing out lithium-ion batteries, which you obviously try to avoid because that's why you go for this type of technology, but there's also that option. And then the environment, less emissions during the charging. But to be fair to lead acid, modern high-frequency chargers used on lead acid these days have become much smarter in their charging cycle. So that minimizes the hydrogen gassing that you years ago got from your lead acid batteries. Also, the recovery and the recycling of lead acid batteries is much higher than lithium, but this is still something that needs a lot more attention, and we need to study the full life cycle and supply chain of these technologies, from sourcing to mining, the elements, and understanding the disposal of all these and how it impacts the environment. If we then jump to some of the negative considerations, cost. Lithium technology has become more attractive in terms of pricing with the advancement in technology. However, the price is still 2 to 3 times that of a conventional lead acid battery. And while it may be more efficient in the long run, some businesses may not be able to afford the initial capital outlay. If we look at the peak demand, the key parameter for electrical billing is your peak power demand. Now, this is part of the equation which is not always considered as part of the payback of a lithium-ion swap over. Whatever the maximum kVA demand in the month is what the user will be charged against, even if it was for a very short spike. So with lithium, the tendency and the selling point is always to charge in between tea breaks or lunch breaks or whenever there's an opportunity to charge. But of course, if all your machines are charging in these breaks, that spikes your demand for that short period, and that increases your electrical spend, which you'll be billed on for the rest of the month, and that could be quite an excessive cost. Also, lithium charging requires more input power than the lead acid due to its faster charging, which also then adds to your increased kVA. But that being said, there are sophisticated battery management systems which you can manage the sort of preset maximum demand that you'd like to look at to manage that max demand to ensure your electrical bill is kept in play. The other thing would also be a challenge is your user discipline. If the approach is to charge between breaks, if the users have poor discipline of doing this in these breaks, you'll obviously run out of power very quickly. And with the thinking of not having a spare battery available, you might be sitting without a machine to be used, since you have to first charge your machine. In a swap out system, obviously, there's always additional batteries available to ensure continuous operation. The replacement life cycles, lithium-ion batteries last longer than lead-acid counterparts, and the batteries outlive the life of the lifting equipment. And this means that the battery life will depict suitable lifting equipment and may restrict your advances in technology based on the release of new equipment models. So if your machine only lasts for 3 to 4 years, but your battery goes to 6 years, you're stuck with that battery for a longer piece of time, which might restrict you in some instances and in your operations. And space utilization, that's also something to consider. Where do you park all these machines while you need to charge? It takes up a lot of space to charge all these machines at the same time. So that's also something to consider when you think about where all these points will be. Also, your electrical infrastructure. In a conventional battery bay, there's a large cable or large power that would go to a single point. With the lithium-ion charging, you might be, due to space constraints, your chargers might be scattered all across the DC, which results in distributed electrical infrastructure networks, which may eventually become more costly. And then also the common one that we all have heard about is fire risks. Lithium is more prone to overheating and fires. It's one of the most dangerous fires and difficult fires to control and extinguish. Although the examples are few, if the examples of the container ships catching light based on onboard batteries causing the fires. It's difficult to contain and it can't be easily distinguished, and most cases are just left to burn. So if, for an example, you had your scattered charging stations all over the DC, and you would that catch a light, and if it's in close proximity of other combustible materials like your pallet stock or any offices, that could also obviously wreak a lot of havoc. So that being said, if we look at some of the criteria in selecting the right battery solution, the equipment requirements is one of the biggest elements to consider. While lithium its largest benefit is its compact size, the battery cycle time is largely dependent on the load weight and the weight of the equipment. So if we say that the load being moved is the same regardless if you're using lithium or lead acid as an example, the only benefit that you're getting is the capability of reducing the weight of the machine so that the battery can last longer per cycle, since you're moving around less mass. But of course, you've got machines such as forklifts, which rely on counterbalances. You've got reach trucks, which also rely on counterbalance in terms of the height that it needs to lift. So at the end of the day, you're also adding additional weight, which isn't part of the battery setup, to offset that, to ensure the machine can operate properly. And that's obviously counterproductive of what you're trying to achieve in terms of saving that energy.
Sorry, Anton, I just want to pause you. It's about 3 or 4 minutes left.
Perfect. Thanks, Mark. Almost done, yeah. All right. So in other applications where the machine is light or smaller, like a walk behind, or you've got a order picker or powered pallet jack, then this obviously makes a lot more sense, where the battery compartment can be made smaller, the machine can be made shorter, and that in turn can reduce turning circles and spaces required to maneuver these machines. What else was there? So I think we've touched on also the machines. I think we've touched on all of that. So on operating environment, the operating environment is of course key selection to battery technology. Think about temperature ranges, frozen facilities, chilled facilities, what products are being stored in the facility, and the overall risk of those products in the facility. Lithium-ion is more suited for cold chain environments, so that's a plus in that situation. But the battery should obviously be able to operate safely in the environment it's destined for. If we look at the battery life and the cycle times, one needs to consider not blindly going for lithium ion as example. You need to consider your shift times, your brake patterns, your operational regimes, and that would then dictate the suitability of lithium or other technologies that you would consider. Somewhere a machine may not have the likelihood of too many brakes, and it may be considered rather that a lead acid application in this specific scenario is better. As we've said, there's always consideration where the lead acid operation might be more suited for a specific operation compared to lithium. So charging infrastructure, also we need to consider the cost of distributed electrical points, the space that onboard charging may require. If distributed away from access points, it may require walking time a lot also for employees during those breaks to get back to their canteens or lunch times, and in effect they have to walk back again. So in that, there's also a bit of lost time in productivity with the staff having to walk further distances if you aren't able to compress all your parking and charging areas in one space. And then finally, also cost. Lithium ion batteries remain expensive and much more than lead acid as an example. And the ratio of lithium may not always be a 3:1. So if you think about that, you maybe need additional machines, or you need more potential swap out of lithium batteries, that might eat into your viability, and it might not then be as attractive as it one thought it would have been. And then lastly, the capex and replacement strategies. Your MHE generally lasts about 15,000 hours or 3 to 5 years, dependent on your working hours of the operation. And this may be the business's view may be to replace the batteries and the machines at the same time in terms of depreciation and opportunities of new technology, and make sure that those coincide. And in most cases, your lithium would outlast the life of the machine, so that might not be in line with the company strategy, considering your depreciation of your assets. All right, so just to close off, while lithium has dominated the mobile energy market, there's still large room for improvement. And circular and sustainable practices will hopefully play a larger role in the development of clean energy going forward. There are many other battery technologies emerging, and we hope to see even more improvements on the sophisticated technology that exists today. Thanks, Mark. That's my introduction to the lithium. I hand over back to you.
Thank you, Anton. Thanks for the informative presentation. It's always good to understand the pros and cons, and also have that holistic criteria for selecting the right battery solution to gain the maximum benefits. I just want to reiterate to our viewers that if you obviously think of any questions during the presentations, please post them to the Q&A tab. We'll obviously try and get to or attend to all of those questions after all the panelists has presented. Okay, so let me introduce our second speaker. Is Mr. Paul Osborne. Paul is the director behind the thriving business known for its innovative products and expertise in the lithium battery markets, named Balancel, particularly in the industrial material handling applications, driven by passion for knowledge, growth, and innovation. Since Balancel developed their first battery management system in 2018, they have cemented its reputation as a game changer in the industry. Welcome, Paul.
Thank you, Mark. And good morning, everyone. Can you all hear me? Mark is coming through.
Yes, I can see your presentation. I can hear you clearly.
Fantastic. All right. So if I can just introduce quickly, as you heard from Mark, Balancel makes lithium batteries and has been specializing in the industrial motive applications for the last 6 or 7 years. What we do different to other lithium manufacturers is really got a lot to do with our battery management system and how we control the energy in and out of that battery. So we to summarize, make a battery that manages itself and protects itself while it's in the field, and reports the use of that battery and the data with extreme accuracy, which allows the analysis of the performance and condition of that battery while it's in the field real time, and can predict any problems ahead of time, allowing for preventative maintenance if necessary, and providing our customers and end users with operational matrix and value-added data and reports. A lot of the intelligence in our battery and what allows us to do things differently is thanks to the battery management system, which you can see on the left-hand side of the screen there. The little box in the center is our battery energy meter, which is really the heart and the brains of the battery. And where the terminal bolts are there, that's connected to our smart electronic switch, which replaces a contact and protection mechanism on other batteries. This is all done internally within our battery, which gives us a lot of benefits, and we don't have to rely on intelligent chargers or the intelligence of the machine that is using the battery, because we can effectively control and manage the energy in and out of the battery ourselves independently. Full range of products can be found on our website. And I think one of the starting blocks in understanding lithium batteries is knowing that there are a whole lot of different chemistries of lithium batteries in the market. Now, we use lithium ferrophosphate, which is most widely used chemistry in industrial applications as well as renewable energy applications. There are 6 or 7 other chemistries, the most common probably being lithium NMC, which you'd find in your laptop, cell phones, your electric vehicles. Now, those scary fires that everyone saw on the ship in the last presentation, those are not lithium ferrophosphate, those are lithium NMC. Lithium ferrophosphate is actually a very safe chemistry. You can Google a whole lot of images and documents about all the tests that they do. They do crush tests and nail tests through these things. They will spark, but they won't. You can short a cell, it'll gas, but it won't actually combust and explode like you do some of the other chemistries. So that's all got to do with the components that are used and the actual materials in the battery cells. Our cells are all automotive grade cells, so they are the highest certification that you can get out of the lithium ferrophosphate cells. All of our battery management system has CE certification, and you can also refer to our website to check up and understand any of those cell certifications and independent tests that are done. But yeah, the biggest difference is understanding the cell chemistry. Another benefit of lithium ferrophosphate is that there are no rare earth metals. So the supply chain and manufacturing of the cells themselves is a lot simpler and less open to those rare components. But also in terms of recycling, we don't have, like you do in the lead acid game, where you've got a lot of weight in your lead that is valuable and used for recycling. In lithium ferrophosphate, the components are recyclable, but they don't have a lot of weight, so there's not a lot of value in it, but it is a highly recyclable product. There hasn't been much investment in this country yet because we're still in early stages of adopting the technology. So although there's been huge growth, in particular in the renewable energy market, as well as the industrial motive market, most of the big increase in production and use of lithium batteries has been in the last 2 or 3 years. So we expect these batteries to last up to 10 years. So you'll see between 5 and 10 years more businesses being established around recycling. At this stage, we use EnviroServe, who are fully certified responsible recyclers, but we don't have much that has been recycled other than physically damaged batteries at the moment. All right, moving on to understanding the difference between lead acid batteries and the benefits really of lithium. I thought the best way to demonstrate this was to take you through a case study briefly. To do this, I've used a large distribution center where they had 2 or 3 large 800 amp hour lead acid batteries going into a reach track in probably one of the busiest distribution centers in Africa. We replaced these 3 lead acid batteries with a single lithium battery, which is a 550 amp hour battery. And equally importantly, we replaced it with a single charger, one small 160 amp charger, which is 8 kilowatts, which is not a hugely energy demanding high energy charger, but it is a fast charger. And if you can see in the images, it's a small wall mounted charger which allows for easy installation throughout the operations. Another safety benefit of lithium is that you don't have those gases and you don't need the ventilation in your traditional lead acid battery charging rooms. So here you can have the charging stations throughout the operations because the battery is sealed and does not give off any of those harmful gases. So there's no need for additional ventilation. On the charger front, that smart electronic switch that I showed you earlier also allows us to use traditional lead acid high frequency chargers. So although you get the best performance pairing our battery with our charger, it also gives customers the option of using existing infrastructure, existing chargers if they like. And you do get a lot of lead acid chargers that are similar kind of energy specification of between 120 and 250 amps that they deliver. All right, so you can view the battery on the right there. Another thing to note in that image on the right is that the battery is built and commissioned in the existing lead acid battery tank. We add about a ton of counterweight steel underneath that battery, and the battery itself weighs about 200 kilograms. Energy density is important because it allows us to offer a number of solutions for any given bit of equipment. So depending on the customer requirements, we can pair a battery. For this reach truck, the 550 amp hour is the biggest battery we supply for it. As you can see from the reports that we pulled from the data, on the very first month of commissioning that battery, the machine was under load and in operation for 510 hours in that first month, which is extremely impressive in terms of an hourly operating time on a single machine. No matter how many batteries you have on it, you won't find many that can match that kind of performance. Another thing about our information and data is it shows you the work rate of this machine. That's the fuel efficiency, if you like, of the machine. Although we list the cycles, that's more an indication of how many times that machine and that battery was able to charge during the period. Now, we're trying to get people to stop thinking about cycles, because when it comes to the cost of a battery, you should be looking at the energy delivered over the life of that battery. So you can cycle it as many times as you like. You want to know how much energy that's going to deliver and how long that battery will last in terms of years in service. Now, our batteries come with a unique warranty that allows for unlimited cycles, unlimited charging. 141 charges during a month equates to just under 5 charges a day.
Sorry, Paul,
yes.
Sorry, I'm going to pause you 2 to 3 minutes left. I'm not sure how many slides you have left.
Only 1 or 2, so we're almost there.
No problem.
So the graph on the left is the state of charge of that machine over the full month. As you can see, it's charged and discharged a lot, but the battery was very well suited, and from 100% down to where it has to go on charge usually takes 3 or 4 days to actually reach the point where it has to go into charge. That is still seen as a bit of a risk by the big manufacturers, the big distribution businesses. So what we've also done, besides building the battery in its traditional lead acid battery tank, which if you have the existing infrastructure, you could remove that tank and replace it with another battery. So if you've got those big battery pools and big battery storage facilities, you could do that. What we've also developed is a small lightweight trolley that a single operator can handle, where we can mount the lithium battery onto rollers within the modified battery tank, and you can very easily remove just the lithium portion. So those images show that prototype in action over there. So the benefits of this would really be to give the end user and the operator kind of an insurance or guarantee that you're never going to be at a point in your operations where you have to go and plug a machine into charge when you really want to use it to move the produce. You can utilize your existing infrastructure, not just the chargers, but your charging bay and those expensive machines to do that. As I pointed out, there is the option of the lithium battery on the actual rollers. It also allows you to reduce the number of charges that you need, because if you've got additional batteries per machine, one of those batteries or the extra batteries are on charge during the day. So you don't need as many charges because you're simply swapping the battery rather than charging in and during your operations. And then lastly, the peak power, which was mentioned earlier, they call it peak shaving. You can avoid those peaks. It smooths out your charging so that you're not all charging over the shift breaks and other operational breaks. So there are many benefits to that innovative solution that we're starting to offer. In terms of the rest of the battery landscape, part of our battery warranty is that at the end of 5 years, or the energy delivered guarantee that we offer, there will be 80% of the original capacity of that battery available in a single charge. So there's a second life for that battery. You can either use it in other machines that possibly aren't working as hard or don't need to charge as often. You could use it in a renewable energy application. But we've got batteries that go into refrigerated trucks, which have renewable energy driven powered applications, last mile deliveries, electric vehicles, and marine applications. So that's it from us at Balance Cell, and I look forward to answering any questions at the end of the session. Thank you.
Thanks, Paul. I see there's quite a few questions coming in, but we'll address them afterwards. I think most of them will be addressed to you, but yeah, let's handle them afterwards. Yeah, I'm glad you highlighted the different lithium chemistries. I think obviously some are more combustible than others, like you rightly said so. Unfortunately, someone reads an article or hears something about lithium batteries are dangerous, and then the automatic assumption is that all of them are the same. But to your point, it's about the chemistry. It's more involved to it.
One last point there is that they're a lot safer than lead acid. I think most of the disasters and fires I've come across have all been lead acid batteries on charge that's short. Lead acid batteries don't even have a fuse. Lithium has fuses, temperature sensors, contactors or solid states, which multiple safety features that we can talk about later.
Yeah, no, 100%. Thank you. It's also good to see that you guys are focusing not just on replacing everything new, is trying to use existing infrastructure as far as you can, like the changeover systems, and there's ways and means of managing the peak power. I think that was also a major concern at a point in time. So this will obviously help keep down the investments, and when changing over to operations from lead acid to lithium, just make that justification a bit easier.
Exactly.
Okay, thanks. Paul. Yeah. So the next speaker up is Mr. Francois Steenkamp. With over 17 years of experience, Francois is a registered electrical technologist with the Engineering Council of South Africa. He's a registered fire detection designer with the South African Qualification Certification Committee and a registered three-phase electrician. His main focus is being a building services specialist, which consists of all the electrical and electronic services within a modern building. Welcome, Francois.
Welcome, everybody. Just quickly going to share my screen here. So there's a lot of items already being discussed regarding lithium and lead acid. So I would try not to duplicate many, but some duplications will there be, as a lot has already been discussed. I have 4 major topics I will just quickly discuss today. What does one consider when designing and sizing electricity in a modern DC? Okay, how is lead acid different from lithium? There's already been a lot discussed about that one. Is there a way to do demand management of supply, and can solar PV be used to charge the batteries? So my first one is what one will consider with your electricity in designing a modern DC. So you need to know the client's requirements. That's the most important one. What type of distribution center will it be? What it will be used for? Equipment that will be used, conveyor belts, forklifts, etc. Obviously, all of the equipment that will be used requires power, and the amount of power requires connections. So that's why it's very important to have that certain info. And what will the lighting requirements be in the DC? The type of activity that will happen there will have its own lighting lux level requirement, and the design will need to be done according to that. Different lux levels require different electricity usages, and that all plays a role. And what backup requirements will the DC require? How does the operations in the DC work? Can it survive load shedding in South Africa? Can it not? Does it need to function 12 hours, 24 hours a day? What will be the best generators, batteries? All of that needs to be considered. And obviously your electricity tariff with your local supply authority, either it be municipality or Eskom. There are different categories depending on the amount of electricity needed for the DC, and you need to choose more or less what will be the best suited for you, because all the different categories have different costs associated to them. And if PV is needed or might be an option in the future, you can immediately start implementing to add infrastructure when designing from the beginning, tying circuit breakers to the main DB, some runs for cables, etc. Obviously your HVAC loading, refrigeration loading, those plays a big role. So what's the requirements of that? And obviously then the size of the DC. So if all of this is considered, then you can determine your connection size and the amount of electricity that will be needed for the distribution center. Okay, here's the topic, the most hot topic, lithium versus sealed lead acid. I'm going to run through a few items here as well. One of the nice items of a lithium, it's independent of the discharge rate, the capacity. Lead acid batteries can drop up to 60% at a high discharge ratio. So you can discharge your lithium battery at a high rate of discharge, and you will still have the amount of kilowatt hours as specified for that battery. Although you get your different C ratings in lithiums, if your lithium battery is rated the 0.5 C, you can only discharge it over a 2-period time and charge it over a 2-period time, all within the 2 hours. But most of your modern better lithium batteries have a 1 C rating, so you can charge and discharge them within 1 hour. Whereas with your lead acids, high discharge, you reduce the total capacity of your storage. And yeah, lithium batteries have up to 10 times more cycles than your lead acid under most conditions, obviously depending conditions. Temperature also plays a big role in discharges and charging of them. Lithium delivers the same amount of power throughout the entire discharge cycle. Lead acid power starts out strong but dissipates when discharging. So about, let's say, 80% down the line, you will have lesser capacity left than with a lithium battery. Lithium batteries charges about 4 times faster than lead acids. So lithium batteries are needed for cyclic applications due to the faster charging. More lead acid batteries will be needed for fast charging applications due to slow charging. You might need to swap out lead acid batteries from time to time, as they do not charge as fast, depending on the usage and your the function they are needed for in the application. High temperature battery performances. So lithium batteries perform much better than lead acids under high temperature applications. So your lead in the graph below, you can see, I mean, your lead acid, 25 degrees, 200 to 300 cycles more or less, where 25 degrees with the lithium, you will push over 2,000 to 3,000 cycles. But if you 55 degrees under lithium, you will still have about 400 to 500 cycles, more or less. Cold temperature battery performance. Cold temperature causes significant capacity reductions on all battery chemistry. Lithium batteries will not accept a charge at low temperature. So below 0 degrees, you won't be able to charge a lithium battery. So it's obviously very important to select the usage and where you're going to use your battery. Lead acids can accept low current charges at low temperatures. Lithium has a higher discharge current at low temperatures, so you will get much more. You can discharge your lithium a great amount under low temperatures. It's a charging that gets difficult. But if you after a high discharge, the battery is still internally going to be very warm. So you need to charge it again while it's internally still hot. Otherwise, let's say if you work at 0 degrees, otherwise you will lose the function of trying to charge it again at those temperatures. Battery installation. Lead acids needs to be installed upright. Lithiums can be installed at any angle, so that's a great advantage. Weight size. Lithiums are much lighter than LSA, about 50%. Storage. Lithium does not need to be stored at 100% state of charge, whereas your lead acid batteries needs to be stored at 100%. It's because of self-discharge rate of lead acids. It's about 5 times higher. So a lot of people keep their lead acid batteries on a trickle charger all the time. Demand management of supply. So demand management, your facilities demand is going to be the demand, but how to manage it to create lesser peaks or lower peaks, because the local authority is going to hit you on pricing on your high demands. So if you can plan your operations, so all does not need to happen at the same time. You can space them a bit, distribute them a bit, that will help. And obviously batteries can be installed to help with peak shaving and the maximum demand usage, and can be obviously the best if you have a photovoltaic installation. You can charge them during the daytime again, or in lower demand periods, which will be the periods, as everybody said before, lunch breaks, tea breaks, that type of thing, when most of the operations ain't happening. And my last point, can PV be used to charge batteries? Yes, definitely they can. Individually creates a problem. You will need to have charge controllers individually. If you will, let's say, individual forklifts try to charge them, the best will be for a photovoltaic installation to form part of the building's entire infrastructure, feeding into all circuits, and then enabling the building to utilize the power generated the best. And I mean, you can even go as far as backfeeding if you generate surplus electricity, or you will generate surplus electricity in periods where the tea breaks, lunch breaks, that type of thing, weekends, if operations are not happening. And yeah, then you can backfeed and sell some of your surplus electricity to the local supply authorities. That's it from my side. Thank you.
Thanks, Francois. Yeah, it clearly shows that lithium does predominantly, from an electrical perspective, have a lot of benefits over lead acids, especially like you alluded to, the power delivery, the discharging and charging. But one can't just assume automatically that lithium batteries for any operation environment is the best choice, because obviously things like the charging temperature environment needs to be carefully considered, amongst other things. But thank you.
So thank you.
Okay, so our next speaker is Mr. Sherwin Putter. Sherwin is a senior mechanical engineer at CKR Consulting Engineers. He obtained his BTech degree in mechanical engineering at CPT in 2010. He is a candidate engineering technologist since 2012 and is currently in the process of his professional registration with EXA. He has a vast range of expertise, which ranges from air conditioning, ventilation, fire, wet services, medical gas, lifts and escalators, fire detection, automatic sprinkler protection, as well as energy efficiency calculations. He is actively involved in projects using lithium battery technologies. Welcome, Sherwin.
Hi everyone, I hope you can hear me. Let me just to start with the increasing popularity of this battery technology in our everyday life. There also comes an increased awareness of the risks that these batteries pose to the workplace that use them, as also noted by Anton a few minutes ago. The aim of my presentation is to try to provide some peace of mind to the risk associated. I will start by going through the list, the following topics. What is the rational fire design? How would council see and understand lithium, the risk associated? What would be considered in a design? What would ventilation play a role in the design? Would this be the same design for power storages? How does one contain a lithium fire? And then how does the asset insurers and underwriters see lithium? So just starting off with what is a rational fire design? The main objective is where I would like to start on what the rational fire design is. The main objective is the 5 key points listed below, is to protect occupants or users of a building. That's actually one of the main focuses for fire protection within any building, life safety. Then one would go to minimize the spread and intensity of a fire. What happens in those cases is, how do you basically stop a fire? How do you reduce the fire, and how do you cut the fire off from the remainder of the building? Ensuring sufficient stability so that the containment or the compartment which the fire exists could or would stay in place for a set amount of time. Point 4 is to minimize the generation and spread of smoke. So how would you suppress the fire? How would you extract smoke out of an area? And then the last point would be to provide adequate means of access equipment for detecting, fighting, and controlling and extinguishing a fire. So the local South African national standard sets out 59 rules to adhere to basically become compliant on a deemed to satisfy approach to the building regulations when submitting any building through to council. If you can tick those 59 rules, then you're sure to be able to get your building compliant or your installation compliant. If these 59 rules cannot be applied to the application or building, then one would do a rational approach to achieve the main objectives as detailed above. So in summary, a rational fire design is the detailed design of a fire safety and prevention mechanism and strategies in the building in order to comply with the national building regulations where prospective requirements cannot be met. Just on this topic and what we see in South Africa, one of the main difficulties with the published codes that we have been faced with in the fire design, the document itself does not generally pin down fire requirements to a single point or draw, let's put it in simple terms, draw a clear line in the sand as to what one needs to do. So this makes it very difficult in certain environments because the codes are open-ended, and a lot of the times these fire designs within buildings generally follows the interpretation approach. So where you would find in certain buildings the one fire engineer or designer does approach it one way, you might approach it different in a different building or installation as such. So because of the open-ended nature of the standards, one normally approaches additional codes or other published codes to try and motivate why your fire design is the way that you have set it out to be. So just going to the next topic, since lithium batteries is rising on popularity all over the world and becoming more regular norm within buildings, and based on my personal recent engagement with our local fire departments, it is evident that our local authority does not have the necessary backgrounds or experience in place on this. Especially so for the topic of how council sees and understands the lithium risk, the local authority or council rely on the SANS fire codes as a backbone for the legal requirements pertaining to a building. So they will always stick to those 59 rules as mentioned on the previous slide to try and show compliance to or with a building that is fitted out with any form of equipment. But those codes, and next point, that the current version of these documents does not specifically address lithium. Therefore, from a legal compliance aspect, there is absolutely no real guidelines on this from our local authorities. Although based on my discussions also, there are various points that come up, but from a legal aspect, there's nothing that is pointed out to actually say that you need to go a certain route with it. So based on my discussion with the local authority, the only items that would be looked at in a condition where there's lithium is extinguishing, containment, and detection. So with increasing popularity of these technologies and also our energy crisis considered that we're facing in South Africa, rising installation of the lithium products, and its associated risk, it is a near given that in the near future, one would see some publications actually coming out of the local authority and legal aspects of what to do or what the local authority would look at in terms of these installations, whether it is with the updating of SANS codes or the South African national codes, or like in City of Cape Town, we could have our bylaws also in place raising this, but it's evident that fire department itself and the local authority does not have the necessary background nor the experience to even fight such fires should they occur, which is a bit alarming, but they are in the process of addressing this. So that brings up the next question. At this stage, what I want to make note of is a common term used across the board in the risk associated with lithium batteries called thermal runaway. Thermal runaway is a phenomenon in which a lithium ion cell enters an uncontrollable self-heating state. The thermal runaway begins when heat is generated with within a battery exceeding the amount of heat that is dissipated to the surroundings, of which may bring me to my next point over here. The following key items are to be considered in the design for storage of lithium batteries. Point 1 is fire, ventilation, leakage, impact damage, overheating, and overcharging. To reduce hazards with batteries, one should always follow the manufacturer's instructions for handling, charging, and storing, since failure to do so can lead to battery becoming unstable, potentially swelling up, melting, leaking, or causing a fire explosion. Thankfully, lithium-ion battery fires and explosions aren't everyday occurrences, but these dangerous incidents can happen when the batteries aren't maintained, charged, and stored in a safe, sensible way. So that brings to be the next question, as mentioned on the thermal runaway also, what would ventilation play a role in the design, and would the same design be for power storages? Under normal operation of lithium battery, it does not give off toxic gases such as other types of batteries, as mentioned before in the lead acid batteries. For this reason, it's not really required to have a constant ventilation. However, for the associated risk of overheating and to try and reduce the likelihood of thermal runaway of lithium systems, it is recommended that the stored batteries are well ventilated, even more so stored in a controlled tempered air environment where temperatures can be controlled and adapted so that the batteries can operate at the optimum level. For this purpose, power storage systems, as mentioned above, yes, a constant ventilation is a definite requirement for the removal of toxic gases. The conventional system does not pose a risk of thermal runaway such as lithium, but it would be advantageous for efficiency purposes to introduce a tempered air solution. So yeah, in a nutshell, ventilation is key and would play a significant role to ensure that storage system is protected against overheating. Then the question, I think that's actually on everybody's mind, and which has been mentioned previously, is how one can contain a lithium fire. So how does one contain a lithium fire? First, we want to start with the basics on fire and what it consists of, as you all know. The fire triangle or chemical reaction of a fire consists of the following three elements: heat, oxygen, and fuel. With the absence of one of these elements, the chemical reaction cannot carry on. A lithium fire has been found to be challenging to extinguish for one of the main reasons of the rapid way in which it burns, but also it has the ability to reignite after extinguishing from a few milliseconds to hours, or even after days that the battery has been compromised. So as mentioned also previously, is that the technology from Relog is slightly different and the risk associated is slightly less. However, my topic covers lithium as a whole. The second challenge with the lithium batteries is detecting a fire. Due to the rapid fire growth rate after ignition, which is likely to happen within a sealed unit, early detection for activation of automatic suppression also becomes challenging. Automatic extinguishing systems rely on detection system for activation. So if there is a rapid growth in fire rate with a delayed reaction of detection, it basically means that the extinguishing process takes longer. So which means is if there's any batteries adjacent to it or other elements adjacent to it, you basically would take longer to extinguish the first fire and it could spread. So therefore early detection is key in these scenarios. There's some triggers for lithium-ion battery fires, which include short circuiting. So it's improper storage, damage, metal dust left over from manufacturing can cause circuits to short circuit, leading to combustion. Then you have the topic of overheating. Extreme temperatures on loading docks, cargo holds can lead to the overheating of fire during transit or storage. That's that brilliant picture that I think Anton mentioned or showed previously. Rough handling, dropping a battery or joistiling it excessively during transport or use the set can also set off thermal runaway. Physical damage from shredding or dismantling battery during recycling operations can result in explosion. Wet and humid conditions, so rainwater, salty and humid, might cause short circuiting and triggering thermal runaway, even without prior damage to the batteries. So then we come to the topic of the means to extinguishers. Numerous fire protection suppliers have conducted various tests to find the best solutions for extinguishing a lithium battery fire. So just in short, the cooling method or the reduction or removal of heat, this method involves pre-action automatic sprinkler protection system. We currently have literature available from FM Global that actually done tests confirming the successful use of this method. However, as everybody knows, and in my opinion, water significantly causes damage to electronics. And in my basic professional opinion, the moisture content of water might be more harming to the system. If one actually Googles it and go onto YouTube and check, if you actually take some lithium and throw it into water, it actually combusted. So it raises the question, does this actually work? My next item is the removal of oxygen contact via chemical reaction. So you can do it via manually operated Class D fire extinguishers. There's actually special lithium extinguishers that is made available for fighting these fires. And then you also get the automatic release aerosol canisters in the event where we also have some tested product information from suppliers showing that the system actually works. Then the third point would be containment. This would basically is creating a fire-rated containment around or enclosure around the system, especially where you're doing the charging of these systems so that you can contain the fire within its place and actually allow it to burn out. So with that said, in summary, in my opinion, as the old saying goes, is prevention is better than cure. Lithium-ion battery technology are constantly changing, and with the safety aspects being constantly improved, they do still pose a fire risk. The key factors to safely use the technology would simply be to handle with care, ensure regular maintenance is conducted, act swiftly by means of a sensitive fire detection, and then choose the appropriate suppression means that would ensure no thermal runaway occurs. In my opinion, from a rational fire aspect, with all the noted in the all noted before, for any spaces I'm faced with, what I would do is I will successfully treat a area that's fitted with lithium-ion batteries, would be to put it within a fire-rated enclosure, have an automatic aerosol or tested aerosol extinguishing system that is triggered by a highly sensitive fire detection system. So yes, with the test results available, there is means to contain a lithium fire, although challenging, but can be done with a correct approach. The popularity of this technology is rapidly increasing, and although protection means seem to be limited, we are more confident that the protection methods, or we are confident that there are more protection methods on its way. And then the last topic that I have is, how does the ASIP insurers or underwriters see lithium? So our local insurers and underwriters rely mainly on the rules set up in the ASIP, which is the Automatic Sprinkler Inspection Bureau, and the SANS, South African National Standards, as a backbone for their fire protection needs. More so ASIP than SANS, as they are a third-party organization who regularly inspect premises to confirm continuous compliance with their rules and regulation. So to date, based on the 12th edition rules and guidelines of the ASIP rules, as well as the SANS, there is no specific requirements to lithium. The most applicable rule is that, as listed in ASIP, is for electrical rooms, which prescribes that the area must be treated with its own fire compartment along with a suppression system, if not sprinkler protected. ASIP does also make note of the previously mentioned aerosol canisters for extinguishing, opposed to sprinklers. So there is no additional requirements, and therefore we've not really been faced with the areas where the batteries as being a concern from the insurers, but I do see it being something that will come up in the future with any latest or new publications that may come up. So at this stage, the only approach to comply will be means of a rational fire design. But with the increasing popularity of this technology, it is a given that there's more stringent rules to be put into place regarding this. So just in summary, yes, lithium-ion battery technology does impose a higher risk to the earlier battery types, but as the technology is being constantly improved, so are the fire protection means, with the various industries constantly running fire tests on these systems. And to repeat what I noted previously, thankfully, lithium-ion batteries, fires and explosions aren't everyday occurrences, but these dangerous incidents can happen when batteries aren't maintained, charged, and stored in a safe and sensible way. Thank you. And that's it from my side.
Thank you, Sherwin. I personally find it interesting that there's no specific guidelines or publication regarding lithium and addressing its fire complacency matters at this point in time. But as you rightfully so said, that the ever increasing usage of these batteries, there's a publication due to be made, and there is still a rationale to be followed, even though the publication is not yet available. What is also quite interesting is that you stated the lithium fire that can reignite after a few hours or even days after the battery has been compromised. Thus, just building a fire compartment of 2 hours or 4 hours on its own without appropriate suppression may not be sufficient. I mean, this might provide sufficient time for the fire brigade to get to the compartment to try and extinguish the fire. However, the risk of reignition is still present. Okay, with that being said, let's introduce our second speaker, Mr. Andy Drage. Andy has 20 years service under his belt, consisting of 11 years as service engineer, 6 years in the technical services as a trainer, junior reach and lithium ion, and UK lithium ion champion. He has 3 years in UK sales training and product management as lithium ion product manager, energy expert and trainer. Welcome, Andy.
Good morning, everybody. Hopefully you can all hear me. Let me start my video. There we go. And share my screen with you. Hopefully, if I click this button here, hopefully, can you all see a presentation?
Yes, I can see the right screen. I can hear you clearly.
Lovely. Thank you, Mark. Well, thank you for that introduction, Mark. As you've probably gathered from my accent, I'm not in South Africa. I'm actually in the UK, in London. But today, I'd like to talk to you all about lithium-ion technology from Jungheinrich's point of view. And with that in mind, briefly, I would like to introduce myself, as Mark said, UK product manager for lithium-ion technology for Jungheinrich, and also energy specialist, specializing in mains, batteries and chargers, not just lithium-ion, but lead acid as well. I'd like to look at 5 topics briefly today, and start with milestones, move on to the key benefits, battery and charger selection, load peak management, and a little bit at the end about sustainability and the environment. So without further ado, let's kick on and look at the milestones of lithium ion, because lead acid, as Anton alluded to, has been around a long time, since the late 1880s. And so it's 140 years old. Has it done a job for us? Absolutely. But times change, and new technologies come along, and lithium ion is seen as a new technology. It's actually not that new. It was first proposed in 1979 by a fellow called John B, and it's pronounced Goody now, not good enough, although still John B. Good enough sounds like he should be in a rock and roll song. But the first prototype was produced in Japan by a guy called Akira Yoshino back in 1985. And the first commercial battery was by a Japanese company, Sony, back in 1991. From Jungheinrich's side of things, they first produced lithium-ion batteries and introduced them to the market in 2011, so what's that, 12 years ago now. In 2018, the ETV216i was launched. I've got a photograph of that a little bit later, you can see, and it was the world's first fully integrated truck with a lithium-ion battery. In other words, the truck was designed and built purely for lithium-ion and not for lead acid. And that subsequently became part of what Jungheinrich called their power line range in 2022, which is a series of trucks that's continually being added to. The great thing about power line and integrated batteries is that instead of starting with a chassis, plonking a battery on, and then building a truck around that battery, if you like, the designers could go a little bit crazy and design the truck and then fit the battery in where it's suited. And there's a lot of benefits to this, in so much as the weight distribution, because the battery is not slap bang in the middle. The counterweights of the truck could be placed in various places, which lowered the center of gravity, making the truck more stable, increasing lift speeds and so on and so forth. But also it allowed, I think Anton alluded to it, with smaller batteries, the actual size of the truck could be made smaller so they can work in narrow aisles. smaller turning circles, which ultimately increases safety. If you've got more room around the truck, you're in a safer environment. Also increased visibility for drivers, which increases the safety aspect. And since 2011, Jungheinrich have supplied over 127,000 lithium-ion batteries worldwide to the marketplace. And as of 2022, 31% of all the electrically powered trucks that Jungheinrich have supplied into the marketplace are in fact lithium-ion batteries. So everyone likes to say they're at the forefront of this technology and lithium-ion trucks. Jungheinrich have been doing it longer than everybody else, and I don't want to give you all the sales spiel, but we've got an awful lot of experience in that field. Now, we've heard of some horror stories and bits and pieces, and as Paul alluded to earlier, LFP technology is really safe, safest chemistry, no cobalt, no rare earth materials. But what are the other key benefits of lithium ion? Well, there's a list here. I don't intend to run through every topic there because that's quite a substantial list, but I guess if I was going to take key points: maintenance free, unlike lead acid, and emission free during charging, unlike lead acid. We've heard about opportunity charging, the availability of that and how fast they can charge. We'll look at that in a little while. We've heard about stable voltage, high numbers of cycles, superior energy densities. But here's the thing: reduced energy costs. So although we would have those peaks during charging, the actual amount of time spent charging means energy costs can be reduced. The reducing energy costs is effectively reducing energy usage, which results in a reduction of CO2e emissions, particularly obviously if you're replacing a gas or diesel truck, but also in the replacement of lead acid. You can possibly look at 12% less CO2e emissions, and in the case of gas or diesel, probably 80 to 90% reduction in your CO2 emissions, and that's a real big ticket item in Europe at the moment. And also, we've heard about capital costs, capital expenditure being higher for lithium ion. There is no doubt about that, but the total cost of ownership of a lithium ion powered fork truck over a period of 5, 6, 7 years is actually reduced, purely because we're using less energy to charge it up, and also there's no downtime, if you like, whilst operators are going off to change batteries. Because let's not forget, a battery change on a on a lead acid may only take 10 minutes, but we've got to consider the time that the operator leaves the pick face or whatever he's doing, drives to the battery change area, takes on board a new battery, maybe has a chat to his mate about last night's soccer results or what was on the TV or whatever it was, and then returns to the pick face. That is all lost production time. So actually the total cost of ownership is reduced with a lithium ion product.
Andy, I just want to also let you know about 2 to 3 minutes left.
Okay. So what are the key benefits? Well, if we look at a standard lead acid battery, we know it's good for heavy duty. If we were to look at low maintenance batteries, really only good for moderate duty. And if we look at gel batteries, really only very good for light duties. Lithium ion batteries are actually good for heavy duty 24/7 hour operations with intermittent charging, if you like, opportunity charging. And a typical curve for a lead acid battery would look something like this. During break times, it's idle. If we were to consider what we call an enhanced lead acid battery with opportunity charging during break times, it'll look kind of like this. But with lithium ion, we can discharge down to 95%. And because it recharges faster than it charges, we can see that actually over the course of a 24-hour period, there's actually no need to change the battery at all, because the charging will recover it back to 100%. Battery charge, and this is the truck I was talking about, the new design reach truck, but charger selection in itself is a science. Battery and charger selection, as we've heard, it depends on customer shift patterns, operator break patterns, implementation during the shift, and energy consumption of the equipment. And generally, this can be calculated using a tool. And here we can see an example of a tool, which I won't run through because I haven't got time, unfortunately. But a tool is used to make sure that the battery and charger are the correct combination, the bath and the tap, if you like, if you're going to look at it that way. Load peak management is an issue we've heard, but there are various ways of counteracting that. There's manual management, shifting T-brakes around so that everything's not on charge at the same time. There are also active load management systems available. You can speak to an energy expert about, and as we've heard, energy storage systems with photovoltaic cells are also an option. Sustainability and environment, big topic in the UK at the moment, but just to show you a few things that, without going into too much detail, that Jungheinrich are involved in quite a few projects there that they are signed up to reduce carbon emissions and become net zero and so on. And also Jungheinrich has actually been awarded EcoVadis Platinum status for the 2nd year running. A lot of different topics go into the auditing of that, but EcoVadis certifies about 100,000 companies worldwide. So to be in the top 100% is something Jungheinrich are very, very proud of. So in conclusion, ladies and gents, we've looked at milestones. We've looked at the key benefits of lithium ion, battery and charger selection very, very briefly, and load peak management very, very briefly, sustainability and environmental issues very, very briefly, which brings me to the end of my presentation that ran a lot quicker than I expected, to be honest with you. But thank you very much for listening.
Yeah, thanks, Andy. Sorry about that. Time is catching up on us.
That's no problem.
I think we can discuss or chat about this for hours and hours on end, but I think there's a few Q&As we can quickly attend to during the session. If I can ask all the panelists just to switch on your videos and mics so that we can have a brief discussion. To all our viewers, we'll obviously not get to all the questions, but we'll send the unanswered questions to the panelists and distribute these to our attendees. And just a friendly reminder, after the session, if you can just fill in the survey, that will greatly help us in improving our webinars going forward. Maybe we need to have less people discussing topics, or might need to increase the time slot. Please, if you don't mind, just answering those questions. Yeah, if I have a quick look here, just want to scan through the questions 1 second here. Okay, so any of our panelists, you are welcome to jump in to the questions, but I'll address someone, and then if someone wants to add anything to it, you are welcome to do so. One question here from Anonymous is, I am of the understanding that Tesla worldwide uses NMC and NCA chemistry in their vehicles, and Toyota MHE uses NCA technology in UK and EU. I assume this is due to the high energy density factor, faster charging capabilities, and longer discharge duration provided by the battery. Why would such huge companies support this product, but you are of the opinion otherwise? I think Balance Cell, Paul, this might be to you regarding your chemistry.
So very quickly, I think Tesla actually are using lithium ferrophosphate in one of their models coming out of China. So there is that, but yes, it's all about energy density when it comes to the automotive industry. So it's just about having something lighter and more compact, delivering the same energy and high C ratings. But you know, in the industrial applications, you're never going to get a forklift using the entire battery in a single hour of discharge, where you might if you're racing around a racetrack in a Tesla.
Okay.
Yeah, I'd just like to add to that, if I can, that Paul's quite right there, and what we need to consider here is that when you're in a Tesla, you may have to drive 300 kilometers to the next charging point. When you're in a warehouse, you might have to drive 100 meters.
Makes sense. There's another question for you, Paul. It's actually addressed to you specifically. Is the lithium-ion technology the last stop in battery development, or is there work being done internationally or even locally on the next generation of technology? Is there something else that you're aware of other than lithium-ion?
I think Andy can also chip in here, and he already has. So thanks, Andy. Lead acid was around for a number of years, and as you can see, lithium's been around. There are a lot of new, an unimaginable amount of money being invested in new technologies and new battery chemistries, but you'll see them coming through in our phones and smaller devices used every day, long before they're going to get into big equipment and machinery. So commercially wise, I think lithium is going to be around for quite some time in the bigger applications.
Okay. And there's a question here. I'm not sure, Francois, maybe, or someone on the panelists might know. What is the average saving in electricity consumption if you convert to lithium? So I assume this is probably from like a lead acid. Does anyone know that offhand?
Well, I can just, someone else can chip in. I'm doing a lot here, but we started off the business building battery management systems that made any battery better. So we installed and built these battery management systems for lead acid and lithium. And recording lead acid batteries during their charge and discharge cycles, in particular the way they charged with the bulk and the equalization charges, we found roughly 35% in excess energy had to be put into that battery to fill it up and charge it fully. Whereas instead of a 65% efficiency, your lithium is sitting in the high 90s. You're looking at 96, 97% efficiency. So there's a significant energy saving simply by moving from lead acid to lithium.
Okay, thank you. Then this is to Sherwin. It says, if a lead acid battery is on the open floor in a large distribution center, the volume of possible hydrogen in relation to the volume of air in the rest of the building is very small. Does one still need ventilation systems in this scenario, or is this regulation more of a risk mitigation?
Yes, so just to answer in terms of that is, yes, it would be more of a risk mitigation. Over a larger floor area, your ventilation component actually just dissipates into the bigger space. My comment in terms of the ventilation was more to where you have grouped packs of batteries stored within one space or one area where these apply. But with regards to in open ventilation, now you won't be able to get the ventilation to address smaller components within that space.
Okay. Let's go through this. There's just a few comments on good performances of the presentations. There's a question, maybe Andy, you can comment on this one. It says, do you factor the time the machine is unavailable while charging versus the swap out time, or maybe even Paul?
Well, generally, the way that calculations are done, certainly at Young Heinrich, is that the battery and charger are of suitable capacity to charge during break time. So effectively, the only downtime is when the operators are on their brakes and not using the trucks anyway. So we don't actually factor that in against battery changing, because battery changing it doesn't take place at tea break.
Okay. And then I think this might be the last question. It says, will capacitive discharge become an option in MHE? Andy, maybe you can comment that one.
I can't see it at the moment. As Paul alluded to, there's countless amounts of money being spent on R&D for future battery technologies, and I totally agree. If we look at lead acid, lithium ion being introduced or first coming to our attention in 1985, it was a full 15 years later before anything else came along. Will it become an option in MHE? I'm not entirely sure. I think we're with lithium ion for the long haul for the next 10 years at least. Definitely.
Okay, I see there's possibly a minute left. Maybe there's one last question I can squeeze in here, running through the list. We already addressed that one.
Mark, there was an interesting one about temperature and performance towards the top. And just in a freezer room environment, or in any environment, the performance of a lithium battery or any battery will decrease with temperature. And it's quite linear. I think for every 10 degrees in Celsius the temperature drops, you lose about 10% of the performance of that battery. So the trick is to actually keep the battery at a room temperature in that environment. And there are various solutions. We either use like an underfloor heating type pad that is powered from the battery, very low energy, or we actually use the cell monitors with the resistance as a little heater to keep it at room temperature. So
yeah, that's good to know. Thank you. Gents and our viewers, I think that's it. We just reached our time. Thank you so much for your presentations and all the information that you shared with our team and all our viewers. We'll obviously, all the unanswered questions we'll send out to all of the panelists, and we'll send that out to all our viewers. I appreciate all your time.
super. Thanks, everyone.
Thank you.
Thank you very much.
Thanks all.